What happens when authorities find a suspicious package containing nuclear material at an airport or a border crossing? How would you find out where that material came from and who was responsible? Because nuclear material can be extremely dangerous, it is internationally regulated. When nuclear material is found outside of regulatory control, a process called nuclear forensics is used to determine what the origin of the material was and how it has been altered. But how exactly is this done? The first step is determining what type of material it is. In general, nuclear material is from some part of the nuclear fuel cycle. This ranges from things like newly mined uranium to spent nuclear fuel, all the way to bomb-ready uranium or plutonium. Because it requires significant expertise and technology to transfer material to different stages of the fuel cycle, finding out what the sample is made from is key to figuring out its history and where it escaped regulatory control. For example, if the material is uranium ore concentrate, then the sample could have been diverted from uranium mines around the world, and the search by investigators is focused to locate a specific mining area. However, if the material is plutonium, then at some point it must have come from a nuclear reactor, and the search can be narrowed to specific types of nuclear reactors. Depending on from where the material was diverted, the sample will contain both material and isotopic clues, called signatures, that can be used by authorities. While traditional forensics looks for fingerprints or DNA, nuclear forensics utilizes isotopic signatures. Determining the compositions of nuclear materials can be done in several ways. For example, if a sample is radioactive, its radiation signal can be used to quickly provide a sample's basic chemical makeup. Tiny portions of the sample can be dissolved, and the chemical contents can be determined. This not only tells investigators what the sample is made of, but also provides clues as to how the sample was produced, which also aids law enforcement. Finally, the isotopic composition of the material can be determined. This requires chemical separation to isolate the elements of most interest. Specialized instruments called mass spectrometers can then precisely measure the isotopic composition of the interdicted material, providing important clues about where it could have come from. When paired with traditional forensics, nuclear forensics can maximize our ability to find out where rogue nuclear material originated, and in doing so, make our world a safer place.